All right, so here I am in SQL Server Management Studio. If you recall, we have our Cogsley Services DB we already built earlier. And now I'm going to create a new database called Cogsley Services DM for Data Mart. One of the interesting things about when you build these is that you don't necessarily just want to take the database you have and figure out how to model that differently. You want to start by actually analyzing how your business works and what those facts and dimensions may be, and then work backwards and let the ETL process handle the process of transforming the database that transacts or records the transactions into the star schema that you built. So the act of building a data mart is very similar to the act of building any other system other than you're starting with that data model. So here what we're going to do, I'm just going to start by doing a database diagram. And when I click that, it's going to say, would you like to install these bits? Yes, I would. And I'm just going to say new database diagram. We don't have any tables here, so I can just hit close. And for resolution's sake, I'm going to hide the Object Explorer. Here I can start adding some tables. And the first one I'm going to add is my sales fact. You'll find it common that in data warehousing or in data marts, you either start or end a table name with the type of table it is, such as fact or dimension. Now, it also could be common where people do something like this, F_sales or D_sales or customers, that kind of a thing. Now, it depends on, I guess, how you think about it in terms of the design or the naming conventions. If you have other systems you've built, you might want to stick with those so people that use it are also familiar with this. I tend to be more on the analytics side, so I prefer things that are a bit more self-explanatory. So I'll start with something called sales fact. Hit OK. Now, a common thing we do is we have an ID. This is called a surrogate key. It's just a random ID for every row that gets written here. So we have sales fact ID. We'll just make that an integer. And we'll go ahead and click on this guy and make it the primary key. So that's just incremented every time a row gets inserted. Now we'll have all the dimensions that we wanted to add. So we'll add something like customer dim ID. This is an int. Product dim ID. This is also an int. Employee dim ID. And I'll pause on this 1 second. So employee could be referenced multiple times here, right? We have a person that maybe sold something, and in Cogsley Services world, we're a consulting company, so we may have a primary consultant again. So you can add the same table basically to your star schema multiple times, but when you have a separate join, you're going to have a separate key to join on. So employee dim ID isn't self-explanatory, right? So let's say I wanted to add salesperson dim ID, and then I wanted to add consultant dim ID, like that. That would make much more sense since we have two roles essentially that the employee table, the physical table which has all of our employees, is actually playing in this model. So when you think about that, it's really important to model your data after the roles and the business types and those kind of things, not so much based on the physical design of the transactional system, which maybe you're pulling your data from. I'll add a date dim ID to join to our dates so we can see that. And again, we have to think about the role that this plays. So that'll be order date is what I'll call it. And then what I'll have here is a delivery date, dim ID, int. Now I'll add a few bits about the sales here. So we'll look at sales amount. So this is actually the first column that actually has data in it about the sales. And for this example, I'm just going to leave that as the last one. So essentially, all of these other fields here are just joins out. They're just keys referencing other dimensions in our design that we haven't built yet. But you can see how basically a fact table is a very simple way to just log transactions that occurred. I'll mention that there are other types of fact tables. They're much more complex and they get much deeper into the idea about how to model these things. So I'll point you where you can learn more about that and leave it there for now. Okay, so we have our sales fact. Let's shrink this guy up, and I'll go ahead and just move him over to the left. Now I'm going to go ahead and a new table here, customer, dim. And when I create this, what we're going to have here is we're going to have the customer dim ID, which is just an integer, and it is the primary key for our table. So we'll go ahead and set the primary key. Now we also probably have a system that has an actual key or identity for the customer. So I'm going to add a field for customer ID. Now customer ID here in this case should line up with whatever the source system was that houses all of our customer information, whereas we're creating one called dim ID, which is our own, what we call a surrogate key. It's our own additional abstraction, our own additional identity just for the data warehouse here. And the reason we do this is because we may have something here like multiple versions of a customer. So the reason we would have multiple versions of a customer is maybe, let's say that the billing address changed and we wanted that was significant for us. Well, if we had a field here, let's call it just address 1, and this is a varchar 50, and then we had city, it's another varchar, state, and country. Well, here what we could do is we could also have a start date and an end date. And so what this would basically allow us to do is have multiple records or multiple versions of the same customer, and we would know that because the customer ID, the business key as it's known, would actually be the same. So we could say, oh, this is the same customer, customer A, but they have different attributes here. Let's say city and state changed, so they would get a new customer dim ID and a different start and end date. That's the concept behind a slowly changing dimension. I'm going to leave this here for now and just know that that is the kind of key concept here about how a data warehouse can track historical changes to your things such as customers, whereas most transactional systems only care about the current value of that. Now this becomes really important when you want to look at historical analytics. If I want to see sales for a different sales team a year ago, I need to know all the salespeople that were on that team a year ago. And that team may look very different today. So that's really a key thing that this data, this concept adds value to your business, is to be able to look back in time and have an accurate understanding of how things looked back then. So I'll go ahead and leave this here. I'll add one more field, customer name, and go ahead and call that one done. I'm going to add product now. I'll add a product dim ID, call it an int, right click on the field and say set primary key. I'll have a product ID. I'll have a product name, product category, product subcategory, product description. Call it end text, which is just another data type here. Similarly, we could have a start date and an end date. As our products change, product lines, we can get new IDs and look at things historically and how they were. So that's a good way to design that table there. You may notice that we could also do something like move product category and subcategory off to a separate table because they themselves have a relationship and save space. And this is where there's a lot of debate about the right way to do this. For simplicity's sake, for our analysts, it's going to be certainly easier to just have the data all in one table. But for maybe the physical design, we could actually spread that out into multiple tables to make it easier to manage. It'd actually store less data, so it'd be more efficient. Then we could do something like create a database view, which combine them into this dimensional or this logical view that we're looking at now. So there's a lot of debate around that. That's just something to point out that if you were looking at something and it wasn't quite designed this way, that may be why, that there's other considerations here. Okay, so we've got our product table, we've got a customer table. Let's build our employee table. Similarly, we'll add employee dim ID, int, this is a primary key. We'll have our employee ID, this is the source system ID, have employee first name, employee last name, employee start date, employee status, employee term date. And then you could also have something here like manager ID, which would join back to the same table. And in the way we would do things here, maybe is you'd have a manager dim ID, which would join back to the dimensional key, because there could be multiple versions of an actual employee, just like there can be multiple versions of a product. Let's say somebody changes their name, for example, and that was a significant change that you wanted to track. You could have multiple versions for every time that occurred for any employee that's in your company. Okay, we're getting there. So we've got 3, and this one we're going to join to twice, so I'll show you how that'll work in a second. So the last one for us to add here is actually the date dimension. So date dim, we'll call it. And here's where there's a bit difference, and dates in general are pretty special. So instead of having a surrogate key, just an integer that randomly increments, because dates don't change, for example, February will always be the second month of the year, we don't have to have this arbitrary other abstraction layer, because there won't be ever 2 records of the same date. The same date will always be the same date. So often what people do, they'll have a date ID, and this will be an integer, but this won't be the random number. It'll actually be an integer representing the date. So for example, 2014-01-01 would be January 1st of 2014. And you can use a format like that and very easily create joins across all your different database tables and all your facts that need dates. So that's kind of a common thing people do here. So for that, we'll have date ID, then we'll have the actual date, then we'll have maybe month, let's say, varchar, and quarter, varchar, we'll call that, year. This could be an int because it's a whole number. And you could add lots of things. You could add fiscal year, add that as an int. You could add all those kind of things. You could add is holiday and call that an int for true or false or 1 or 0. You could add all kinds of things. You could say, is it a company holiday? Is it a federal holiday? Etc. So in your dates, this can be a really rich dimension, and there's lots of other examples online. You could probably go find one that fits kind of what you're looking for and just use that as your example. But I'm just going to leave this here. It kind of has a very basic one so we can get going on our star schema. Okay, so we've built all the tables necessary. Now it's time to link them all together to create those relationships. If you recall from the previous module, we did that. So I'm also going to right-click on this guy and say Set Primary Key. And I have all of my dimensions here. What I'm going to do is I'm actually going to save this diagram. And I'm going to call this Sales DM for Data Mart. It's going to build these tables for me. There we go. The little asterisks disappeared from all of them. And now that we're there, we can actually do some joins. So because of my resolution is tough here, I'm going to shrink this down quite a bit. Maybe we'll go to 75. All right, so you can still kind of see it. So try to make this look like a star, just like we did before. So let's look at dates. And this is where what we're going to do is we're going to drag order date over to date ID. And it's going to create the relationship for me. It did it on date ID, order date dim ID. That's cool. That's what I want. I've got that. I'm also going to drag delivery date over to dim date ID. And hit that guy. So now I have 2 relationships, 2 joins going on there. Then I also have customer. So let's add customer in here. So customer dim ID drags over, building everything for me. This is pretty awesome. I'm going to drag this guy over. Maybe I'll drag this a whole lot of these tables over here. So we have employee dim, so this is where I'm going to have consultant ID joined up to employee ID. And then we'll also have salesperson ID, so we'll have a multiple join here. There you go. And we'll drag our customer one down, so that's there. We've got our dates up here, and we've got our products down here, so we'll add products product dim ID and product dim ID. There we go. Okay, so let me just try to fit this to the view so you can see what's happening here. Apologize for the resolution, but hopefully this makes sense that you have your sales fact, or in general, your fact tables are kind of at the center of your design. And then related to those are all the different dimensions. So if we wanted to enhance this later on, we could add new dimension keys inside of our sales fact table and add those dimension tables as necessary. Similarly, if we had another fact table that, say, needed employee information, I could just use that same employee ID and actually join to that table there. So these assets become reusable, which is how they add value over time. But like you may have noticed here, having to build them all from scratch the very first time is kind of costly, and that's it seems slow. But overall, in the end, it becomes much faster and much better as you kind of collate all these different data sources. And in the end, hopefully you have a really complete picture of your business and how everything fits together.